Hello, my name is Peter Milton and I am the developer of TimeChainage. This is the first of a two-part tutorial where we look at adding progress using the actuals form. With conventional Gantt charts, showing progress against a plan is useful as it shows whether the works are ahead or behind schedule and by how much. With TimeChainage charts, showing actual progress against the plan becomes much more informative, and this is one of the powerful features of the TimeChainage format. If you add regular progress, say daily or weekly, you can see not only are you ahead or behind your planned position, but also whether you are achieving your planned progress rate or not. For example, if you are behind program, you can see if you are catching up, staying steady, or falling further behind. Equally, if you are ahead of program, you can see if you are improving further, going at the planned rate, or starting to lose ground. Seeing the actual progress rates on the chart makes it easy to forecast the completion date based on progress to date. Now, of course, this can all be done with tables, but tables do not communicate the story as well as a good chart does. Showing a TimeChainage chart to the stakeholders will be instantly convincing, and no one can argue about the facts when they are shown so clearly. Showing progress on a TimeChainage chart has some advantages and some disadvantages over a Gantt chart. To explain why, it will be helpful to make a distinction between linear and non-linear tasks. With linear tasks, TimeChainage charts show more information than the traditional Gantt chart, in that they show progress rates and can show detailed progress history, including daily progress if desired. This makes TimeChainage charts far superior to Gantt charts for showing progress. With non-linear tasks, the situation is a bit different, and from a TimeChainage perspective, the way we show progress needs thinking about. The issue being that as-built lines and shapes can sit on top of the planned tasks, making the chart messy and difficult to read. However, TimeChainage was designed to give you flexibility in how you choose to show progress, and this tutorial will explain some of the ways of displaying progress in a clear and meaningful way. There are two main ways of recording progress in TimeChainage. One method is to make a baseline from your current plan, then update the plan in the planned form using actual progress data. This would usually be done once every reporting cycle. Once updated, you end up with a new plan with new forecast dates plus an accurate as-built program for the works to date. This data can then be compared with your previous period or any other baseline you have saved. This method is suitable for overall project updates, especially if there are a lot of non-linear tasks in the schedule. The second method involves adding progress activities in the actuals form. Tasks in the actual form are not linked to planned tasks other than through the WBS and activity codes, so the plan is not changed in any way by adding actuals. Actuals can then be compared with the plan or indeed any saved baseline. With this method, you can easily and quickly update progress on a much more frequent basis, even every day if you wish. You can send out progress and forecast reports, daily or weekly say, allowing the management team to react quickly to changing events. This method is most suitable for individual linear tasks and is one of the features that makes TimeChainage unique. For this tutorial, we will look at the second method where we use the actuals form. I have an example project open that we can use for this tutorial. This example shows real data from a project from a number of years ago, as can be seen from the time axis. The chart shows the sinking of a sprayed concrete lined shaft as part of a much larger project. The horizontal axis in this case represents depth of excavation. The chainage values on the horizontal axis are levels in meters. So ground level was at around 104 meters above datum, and the formation level was at around 55 meters above datum. The blue line is the plan prior to excavation commencing, and the red line shows the actual progress. Several different production rates were assumed in the plan, and work was to be undertaken on a 7-day working week. As can be seen, shaft sinking started on time, but the achieved production rate was generally less than planned, shown by the red actual line being at a steeper gradient than the blue planned line. The longer this went on for, the bigger the gap between the planned and actual progress. The vertical distance between the lines represent the variance in time between the plan and the as-built for any chosen chainage. The horizontal distance between the lines represent the variance in chainage on any particular date. The vertical sections of the line represent no progress being made, so for the planned lines, this was for planned stoppages such as bank holiday weekends and to construct the eye for a mid-level connection. For the as-built line, the mid-level connection eye had a change of methodology which took much longer than planned, and there was also an unplanned stoppage due to a plant breakdown causing further delay. Last-minute changes to methodology, while disruptive, are not all that unusual. In this case, the sequencing of work around the mid-level connection was changed after shaft sinking had commenced. The change in plan is clearly shown in the time chainage. Excavation continued below the connection level, followed by a backfill activity. The backfill then had to be removed after the connection eye was constructed. The reason for the change in methodology isn't important here. What is relevant is that the new sequencing and impact is clearly shown in the time chainage. For this method, we enter actual progress in the actuals form. So let's start by taking a tour of the form. We can access the actuals form from the data menu and selecting actuals. Or else we can click on the actuals button in the toolbar. This one here. Let's use a button on the toolbar. The actuals form is similar to the plan form in some ways, but with some significant differences. Across the top is a toolbar that includes quick filters. In the middle is the input table where you add actual progress in the form of activities. You will see that the column headings are not the same as for the plan form, and we will look at why shortly. At the bottom is the details panel, which has two tabs, General and Summary. When you click on a row in the table, details of that activity are shown in the details panel. You can enter data into the table directly or from the General tab in the details panel, or a bit of both. The Summary tab in the details panel is information only. You cannot edit or change data there. Then there is the status panel, which shows number of tasks, total length, total duration, and average rate. The toolbar consists of two panels. One contains buttons for adding and deleting tasks, moving tasks up and down in the table, a button for saving the current order the tasks are in, a button to sort the activities by the saved sequence, a schedule button, copy to the Windows clipboard and paste from the clipboard. Finally, there's a button to close the actuals form and return to the main form. The second panel contains quick filters for the WBS, activity codes and the WBS code. If you have a large project with many actuals, these filters allow you to quickly find activities you want to access. Probably the best way to learn about actual activities is to add some using the table and the details panel. For this, I will use another project with no actual tasks entered. So let's leave the actuals form by clicking on the close button in the toolbar and then opening another project. To do that, I go to the File menu and select Open. Then we navigate to where the project file is located. In my case, it is on the desktop. We click on it and press Open. This example is a very simple project with just a few planned activities in at present. The project consists of two shafts and a connection tunnel. Let me show you the plan form. We open it using the button in the toolbar. For the sake of clarity in this tutorial, we have just a few activities representing the shaft and tunnel works. In a real project there will of course be many more activities, but keeping things simple will help us understand the principles involved. The important things to note here though are the WBS and activity codes. It is through the coding that we link the planned schedule and the actual as-built progress. Note we do not link activities, just the works as described by the coding. So for this example, we are going to be looking at the tunnel drive, and we have two codes we will be using, the WBS and activity code 1. If we click on one of the tunnel drive tasks, we see it has a WBS value of tunnel A to B and an activity code 1 value of drive tunnel. Note that in this project we have named activity code 1 as work type. So in this project the WBS describes the structure being constructed and activity code 1 describes the nature of the work. Now we don't have to use the WBS and activity code 1 to map our planned and actuals together. You can use any one or combination of codes you deem to be appropriate. Don't forget you can filter on these codes, and that allows you to design layouts and reports to target just the tasks you want to look at. Let's leave the plan form by clicking on the Close button in the toolbar. I'll just open the WBS and Activity Code 1 forms to show you what is in there currently. We can open the WBS form from the toolbar using this button. Here you can see we have just the 3 values showing the structures that form the project. 2 shafts and a connecting tunnel. We are interested in code reference 3 for this tutorial. We close the form and open the Activity Code 1 form. We do this from the Data menu and selecting Activity Code 1. Here we have a few values describing the type of works on the project. The value we are interested in today is reference ID 4, Drive Tunnel. Let's close this form and start adding some progress. We do this in the Actuals form, which we open either from the Data menu selecting Actuals, but we will open it using the button in the toolbar. We are greeted with a blank table as we haven't added any Actuals yet. For this tutorial, we will ignore the shafts and just add some progress for the start of the tunnel drive. To add our first activity, we click in the blank row in the table and some default values are automatically entered. Alternatively, we could have pressed the Add button on the toolbar. Let's change the defaults to real as-built data. The first column is a reference ID, which is automatically created. You cannot change the ID values. The second column is the WBS value. In the table it is shown as a number. For the description we need to look in the Details panel. Here we see it has defaulted to shaft A. We however are going to enter progress for the tunnel drive, so we click on the downward arrow to open the list of possible WBS values. Here we select tunnel A to B. Note that in the table the ID for this is 3. The next 2 columns are for the start and end date for this segment of progress. Our tunnel drive should have started on the 13th of September according to our plan, but a small delay means it actually started on the 15th of September. Now we can type this date directly into the table, or else we can select a date from the pop-up calendar in the Details panel. We click on the downward facing arrow in the Date Form section and select the 15th of September. We now do the same for the date 2. In this case, I will enter in progress for the first day only. You can enter any period of time in whole days though. I will enter 15th of September. If you enter the same date for both date from and date 2, TimeChainage knows you mean 1 day of work. Next we need to enter the chainages, and I will do this directly in the table. The tunnel drive starts at chainage 0. And the first day's progress was 2 meters, so I entered 2 for the chainage 2. We can then enter a description if we wish. I will enter the production rate 2 meters per day. Just like with planned tasks, you can display the activity description on the chart, so use whatever description you feel is most appropriate. I want to show the production rates. Now if we press the return key, the calculated columns get updated. In this case it is the duration, length and average production rate. The next column is called line or box. There are actually 3 options here, line, box or milestone, as can be seen in the Details panel. For this task we will leave it on the default value of line. The last bit of data we need to enter here is a value for activity code 1. In the Details panel, we click on the downward facing arrow in the Work Type section to open up the list of code values. Remember, we gave activity code 1 the name Work Type. We select Tunnel Drive and notice that the reference ID for the tunnel drive is shown in the table as 4. Note also that we have not entered a calendar for this activity. As we are entering as-built information, there is no need for calendars. Let's add a second actual activity. While the first task is selected, you can use the down arrow on the keyboard to generate a new activity, but we will use the Add button in the toolbar this time. Note that the default values are now based on the previous activity. So TimeChainage assumes the date from will follow on from the last activity, being the next day, and Chainage from will be the same value as Chainage to on the previous task. The WBS and any activity codes will also be the same as previously. This saves time when entering data. For the second task then, I simply need to enter a Chainage to value. In this case it is 3.5 meters. By pressing the return key, we see that the production rate is 1.5 meters per day. So I will enter that as the description. Let's enter a couple more tasks using longer periods of progress. This time we will use the down arrow key on the keyboard to add a new task. I will enter 21st of September as the date to. This tunnel drive is on a 7-day work week, so the weekends are being worked. The Chainage to is 16 meters. Pressing the return key, I see that the average rate is 2.5 meters per day, so I'll enter that in the description. We'll add one more task. The date to will be 28th of September. And the Chainage to will be 55 meters. This gives an average rate of 5.57 meters per day. For the description, I will round it off to 5.6 meters per day. Let's take a look at how this appears on the chart. We close the form by clicking the Close button in the toolbar. The layout we have open at the moment doesn't show actuals, as it is just showing the plan. We can show the actuals on this view though, simply by checking the Actual filter in the toolbar like so. Hopefully you can see a red line appear at the bottom of the tunnel drive. If I zoom in, it becomes clearer. We'll zoom out again. We are interested in monitoring progress of the tunnel drive only, so let's create a new layout for just that. First we will create the filters. We access the filter form from the Format menu and select Filters. This is where the WBS and activity codes come in useful. Let's click on the new WBS filter. We will give the filter a name and call it Tunnel A to B. Then we will select only Tunnel A to B planned and actual tasks. We will also click the Hide by default any new WBS values. We then click OK to create the filter. This filter on its own will show all of the Tunnel A to B works, including the TBM install and removal and the secondary lining works. However, we only want to see the tunnel drive. So we need to create another filter using activity code 1, which as you remember we made for work types. We start by clicking on the new activity code 1 filter. The filter name will be Drive Tunnel. We will press the Show None button, then select to show the drive tunnel value. We will then select the Hide by Default option for any new values we may enter in the future. Then click OK. We make sure the Apply filter is checked for both filters and then check the OK button to leave the filters box. Now we see just the tunnel driving works. And because we have the auto range control turned on, the full tunnel drive fits nicely in the view window. All we have to do now is save the layout. To do that, we go to the View menu and select Layouts. We press the Add New Layout button. We will give the layout a name. Let's call it Tunnel A to B Showing Progress. We make sure both planned and actual tasks are checked. Then press OK. Our new layout is shown in the option control. We click on Open Layout. We now have a layout showing just the tunnel drive with a blue line for the plan and a red line for actual progress. Let's add a data date line. To do this, we go to the Annotation menu and select Data Date. Our last progress item finished on the 28th of September, at the end of the working day. The data date in TimeChainage is a zero time event occurring at the start of the day. Therefore, we want the data date to be 29th of September. In the data date section, we select the date as 29th of September and check the Show Data Date Line option. By default, the data date text is shown close to the left-hand side of the chart. We need to move it a bit to prevent the text being on top of the progress line. So let's set the text position to 40%. Then we click OK. We now have a data date line. As you can see, the text for the actual progress looks a bit messy as the tasks are short. There are several ways we can deal with this, but let's just rotate the text to be horizontal rather than the default, which is matching the gradient of the lines. We do this in the Annotation menu and select Actuals. Here we make sure that we have the description shown, all the tasks are shown, and set text to line gradient box is unchecked. We then press OK to close the actual annotation box. As we have made some changes to the layout, we need to resave it. The quick way to do that is to press the Save Layout button on the toolbar. Now suppose we come in a week's time to add more progress, but there hasn't been any due to a plant breakdown. How do we show that on the chart? We can simply not show anything at all, or else we can positively show no progress by adding a vertical line for the stoppage. On TimeChainage charts, a vertical line shows that no progress has occurred for the duration of that line. For this option, we can also add a description to explain on the chart why there was no progress. Let's do this option. We open the Actuals form from the button on the toolbar. We click the Add Task button. The date from date is correct, but we change the date to 5th of October. The change from value is correct, but we will modify the change to value to 55 meters, the same as the change from. This is because there has been no progress. In the description field, we enter plant breakdown. And then we press enter. You will see in the calculated fields that the duration is 7 days, the length is 0, and the production rate is 0. You could, if you wish, create an activity code value for unplanned stoppages. We won't do that here, but there are a number of advantages in doing so, especially on a large project, as you can filter for stoppages and produce statistics for reporting. Let's leave the Actuals form and see the updated chart. We need to move the data date, so let's open the data date dialog. We set the new date to the 6th of October and press OK. We need to save the layout again so it incorporates the new data date, and we do this by pressing the Save Layout button on the toolbar. Let us now see what the completed tunnel drive looks like. I won't make you watch me fill in the rest of the progress, but the process is the same. Right, so here we have the full as-built, and as you can see, after the stoppage, production improved and generally bettered the planned rates. The drive was even completed a day or so ahead of plan. A Gantt chart will not show the story in anything like this level of detail. We can see some statistics as well very quickly. If we open the plan form and filter for just the tunnel driving activities, we can see from the status bar that the length of drive was 725 metres. The duration was planned to be 82.5 days, with an average production rate of 8.79 metres per day. We can compare that with the as-built by looking at the actuals form. Again, we filter for just the tunnel drive activities. From the status bar, we see that the actual driven length was 725. The duration was 80 days, giving an average production rate of 9.06 metres a day. The tunnel was driven 2.5 days quicker than planned. These stats were of course available throughout the tunnel driving, providing some basic but useful reporting data. We can obtain more statistics by looking at the project statistics form in the reports menu. That will be too much for this tutorial, as it has been long enough already. Well, that's it for this video. To sum up, TimeChainage gives you flexibility in how you enter and use as-built data. The actuals form is useful when you want to include detailed progress for specific linear tasks, and this gives you a very clear picture of how well the task has progressed compared to the plan. In the second part of this tutorial on the actuals form, we will look at the different line types available, how you can use actuals for non-linear tasks, add in an updated forecast, and a bit more on using the actuals form. Thank you for watching, and I hope that you found this video helpful. TimeChainage, adding an extra dimension to your schedules.